I'm Leslie Eloise. I'm Vice Principal and Head of the College of Science and Engineering. And I have to say it's one of the pleasures of my job to host inaugural lectures, because they're always informative and entertaining. No pressure.
Thank you, thank you.
And they allow me to congratulate the University of Edinburgh on hiring a superstar. Loads of pressure.
Absolutely.
Tonight, it gives me great pleasure to welcome Gordon's many guests and colleagues. In particular, I'd like to welcome Gordon's wife, Linda, and his sister-in-law and brother-in-law, Carol and Ian Osborne. I'm also pleased that Sir Tam and Kathleen Dayal, who are long-term supporters of the university and of yourself, Gordon, are here tonight as well. Now, Gordon, as I'm sure you're all well aware, is one of the best networked people I know. And to prove it, his guest list is impressive. I'm not going to list you all, because I'm bound to miss somebody out, but you're all very, very welcome. Thank you for coming. Gordon is an undergrad alumnus of this fine university, and he was appointed to the chair of Future Infrastructure last year after a stellar career in industry. He was vice president of Jacobs Engineering prior to retiring last year after 40 years in the engineering industry. He was president of the Institution of Civil Engineers and also the Institution of Engineers and Shipbuilders in Scotland. Gordon was the UK government's project representative on Crossrail, and currently he sits on the independent assurance panel for the HS2 rail link. He's been recognised by the award of an OBE in 2008 and honorary degrees from Glasgow Caledonian University and Heriot-Watt University, as well as many other countless prizes and awards. Gordon has now come out of retirement. It didn't last very long, to take up the newly created chair of Future Infrastructure. And this chair is designed to promote research that helps policymakers address large-scale challenges, mainly in transport and utilities. Gordon is leading the Future Infrastructure Research Centre, which will pull together colleagues from across the college on projects such as high-speed rail, low-carbon energy, and sustainable water supplies. In his spare time, Gordon has served as Vice Chair of the Royal Commission on the Ancient and Historical Monuments of Scotland, and is the founder and current chair of the Scottish Engineering Hall of Fame. In his YouTube presentation on the Hall of Fame, Gordon states, "Scotland, for a small country, has punched above its weight in producing great engineers." So let's hear from one of them. Gordon, it gives me great pleasure to introduce you to give us your inaugural lecture entitled Back to the Future, Infrastructure for a Changing World. Thank you.
Thank you very much. Oh, thank you very much, Leslie, and good evening, ladies and gentlemen, fellow engineers, and those lucky enough to be close to engineers. How's the light at the back? Should I leave it on a little longer? Yes. I'm not really a conventional inaugural lecturer. The honour is bestowed on new professors of the university. To set the scene, I suppose, for an exciting and a long career ahead. And most inaugural lecturers, whilst they're not necessarily in the first flush of youth, are at least not in the final flush. I must have at least a claim to be Edinburgh's oldest ever inaugural lecturer. Nor am I conventional, apparently, in delivering a lecture so soon after arriving. Apparently, for some professors, it takes years to deliver their inaugural lecture. It's 15 months since I took up the post of Chair of Future Infrastructure, but it's on a 40% contract, So that's really 6 months. And deduct from that holidays and the first 3 months of wall-to-wall inductions, safety briefings, and I think I've had about 6 weeks productive time to do something original. So I hope at least you enjoy the sandwiches this evening. I titled my lecture, I'll put the lights down a little bit now. I titled my lecture Back to the Future, not because I'm a particular fan of Marty McFly or Doc Emmett Brown, who you see here, but Doc Brown certainly displays a conventional image of the slightly eccentric inventor and engineer, perhaps only just slightly less intimidating than the public's perception of a typical scientist. Sorry, Leslie. And whether we like it or not, image is actually important, especially now that we're told regularly that we live in a post-truth society, whatever that is. Unsubstantiated opinions, impressions, the more extreme the better, often carry more weight than evidence-based facts sometimes. And we are told that experts are to be distrusted, whatever they say about the economy, about the future of our country, about the future of our infrastructure, perhaps, because their views are not in tune with the vast majority. Well, we have actually progressed moderately well by holding to the belief that education leads to an understanding and a better, more informed future. So let's hope that when we look back on some of the more bizarre claims and statements of 2016, we see them merely as a blip in the appreciation for expert opinion in science and engineering knowledge generally as a worthwhile commodity, and of engineers as the adopters and the developers of that scientific knowledge base, who then build the infrastructure that supports and advances our civilization, which ultimately defines our quality of life. And contrary to Michael Gove's apparently considered but inexpert opinion, we do need experts, perhaps even especially expert engineers. We need them because they're our best shot at building a better future. So, what does an expert engineer look like? And I'm going to stop using the word expert because I'm fed up doing this now. What does an expert engineer look like? I've said it again. Well, I looked up as now a blooded researcher. I started where all researchers start, by Googling engineer, and really to get a view for the impression of what came up. And I was quite pleasantly surprised that far from the pale, stale male convention that I thought I would see, the very first image that's associated with engineer is Kitty Joyner, who's a 1950s aeronautical engineer. So that's actually quite encouraging, but it's not actually typical, of course, because only 9% of engineers in the UK are women at the moment, which is actually quite an embarrassingly bad statistic, aggravated by publications like this that I had in my library from the 1960s or 70s or so, A Young Man's Guide to Civil Engineering. And the fact that we all laugh at that now shows that at least our conventions are being gradually overturned. The bad news is that there was a whole family of these books for the Young Man's Guide to just about everything. So that's the baggage that we've got in our attic that we have to overcome at the moment. A search under Google Image tells a more expected outcome, perhaps. Lots of hard hats, lots of paper plans being unfolded, and out of that lot, there are only 2 images with women engineers. I'm a civil engineer, as Leslie said in the intro, and I suppose I'm better informed to take a view on, if not an expert view, on the view that ought to be represented by civil engineering, and there it is, not much different from engineering, to be honest, but more of this sort of rolled up paper plans, hard hats again, and quite a bit of narrow-eyed gazing over a landscape that's as yet undeveloped with wonderful engineering, but ought to be. Let's take a bit of a look at the one to the left of the second row, in which there is a view of the Falkirk Wheel. And if there's time, I might have something more to say about the Falkirk Wheel later. But that image I wanted to have a closer look at is this one. This is from a careers site, reasons to become a civil engineer. And on the face of it, it looks fairly obvious, but when you look more closely, you see again the paper plan. You see a set square, and pencils and pens. You also see safety glasses. That's good, that's encouraging, safety conscious. But you also see a builder's spirit level. Now, I can't remember the last time I took a builder's spirit level with me on a site visit. In fact, it's never. The foreman wouldn't have allowed me to do that, to check true. And there's also a set of headphones on the right-hand side of the image. I suppose that might appeal to the young, I guess. There's also a magnifying glass. Now, that must be something to do with the years that you spend poring over plans and details, ruining your eyesight. I don't know, but again, it's a kind of odd artifact to be associated with the civil engineer, who himself, I'm assuming, yes, it is a man, I would say, who himself is obviously very safety conscious, because he's even wearing his hard hat in the drawing office. So that's, perhaps there's a clue that the attribution at the bottom is written by admin. But anyway, this is, we do get saddled with impressions and image, and the paper plans, despite the fact that they're now largely replaced by iPads or tablets, which, by the way, are really good if your eyesight goes, just a kind of expansion of the fingers. It saves that magnifying glass that I was always losing anyway when I was carrying it around with me. But we can become burdened also with the past, and impressions take an awful long time to change. I mention this because in 2000, I put together a short talk on the representation of civil engineers in fiction. Precious few of them, by the way. And in 2006, I launched a prize for scriptwriters or novelists that had been published writing about engineers. I teamed up with some other institutions at the time. And the prize that we had available was actually more valuable than the Booker Prize at the time, but the oxygen of publicity was a little bit less. We did award a prize, and that was to the computer game software company who had written Lara Croft Tomb Raider Legends. And her fictional sidekick in that computer game was a young woman civil engineer doing voluntary work in the Amazon rainforest. So absolutely perfect. And had obviously a lot of users impacting on that particular representation. My premise was at the time that until we get the profession of engineering as familiar and attractive and desirable to young people as law, as medicine, as forensic science has become, as veterinary science has become, using the power of fictional role models, then we'll still struggle to get the best talent into engineering. So engineers have still got a lot of hard work to do on their image, because we're not yet getting much help from the media, despite some excellent work being done in documentaries. And I'm by no means the only professor of engineering at Edinburgh with an IMDb profile. And well done, Professor Luke Bisbee, who unfortunately can't be here tonight. He's filming the next episode of Impossible Engineering, I think. But it's not, to be honest, it isn't documentaries that really make an impact on the psyche of young people. It's the role models that they see week in, week out. Mid-career professionals today, some of them will have been influenced in their early teens by watching Ally McBeal, if they're a lawyer, or Rachel and Ross in Friends, or George Clooney in ER. It's the characters in drama and sitcoms that they want to emulate. And scriptwriters rarely write about engineers. Engineering UK is estimated that this country needs 182,000 new engineers every year for the foreseeable future, and we produce nothing like that. We'd greatly benefit from role models if they existed on the television on a regular basis. So in their absence, it just means we have to work even harder to get the message to schools, to teachers, to parents. We need to engage properly with half the population for a start. So why is that? It's because the future of infrastructure needs and likely expenditure to meet them worldwide is absolutely huge. This is a series of statistics from a McKinsey review which estimated about $3.3 trillion per annum of economic infrastructure would be required through to 2030. And that doesn't even include that wall between Mexico and the USA. So, and $1 trillion is a hard number to get your head around. Say that you earned $100,000, we'll stick to dollars, keeps the maths simple. Say you earned $100,000 a year. It'd take 10 years, obviously, to earn $1 million. 10,000 years to earn $1 billion, and 10 million years to earn $1 trillion. So when you start talking trillions, you tend to lose a sense of scale. So let's just say if you like designing and building stuff, there are plenty of opportunities, virtually boundless. But hang on, we've got this massive amount of infrastructure that needs to be designed and built, but we're short of engineers. So how do we square that? Can we do more with less? Well, to a degree, that should be possible. Most industries improve their productivity year on year, don't they? But unfortunately not apparently for construction. This survey was done in the US, and the construction industry productivity from 1964 through to 2012 actually fell 19%, unlike all of the other industries. The non-farm labour productivity. Actually, even if you added the farm productivity, it didn't make much difference to that graph. Construction stands out as having a reducing productivity. And it's not likely to be different in the UK or anywhere else. We tend to have common approaches and processes. So how do analysts explain that poor productivity performance? Here's a World Economic Forum explanation, including multiple stakeholders, no mass production, every project is a prototype, fragmentation of the industry, low margin business, boom and bust cycles, unstable workforce. And I'd like to add to that, it's not there on that list, low investment in R&D and being slow to innovate. And construction's not very integrated. There's a colossal many-tiered supply chain feeding a smaller number of major delivery organizations. And if those major organizations are involved at all, and in many projects they're not, because they're done by fairly small contractors and fairly small design houses, each interface requires management, negotiation, commercial deal making, with potential for relationship breakdown. So it's a complicated and challenging, multifaceted business. Now, this requires a bit of explanation. A piece of work's been done that shows that the required degree of collaboration to deliver a construction project is twice the next closest industry that was in the study. So, explaining that. The red in this diagram signifies internal organizational information flow, and the blue is external collaboration and information flow. Now, in the software and the media and the entertainment and manufacturing financial services, the vast bulk of information exchange activity is internal. And in construction, there's significantly less internal and far more external communication. And at first, that sounded odd to me, that we're collaborating externally far more than all of these outward-facing industries. But when you think it through, all these other sectors spend a huge amount of time developing and creating product. which in many cases they want to keep secret. They've got long periods of discussion, debates, meetings internally. They refine their designs or their film or whatever it is they're producing, or their new piece of software, their new piece of hardware, and then they launch multiple products through their sales force to the market. That's the end of a very long process of internal development and design. They don't need much in the way of third-party approvals during that process, typically. They don't need acts of parliament to get their product to market. They don't need major public consultation, just as much as their market research requires. That's their decision. Basically, just get on with it, and they do their best to sell what they've created in as large numbers as they can. And construction isn't like that. Civil engineering isn't like that. The project team has to start consulting before the design even starts. The environmental impact statement, for example, feasibility studies, planning permission, public consultations. Government influence is a factor on the bigger projects. Change of government, if the job drags on long enough, and many of them do. Affordability limits, change of affordability limits, all of those requiring external stakeholder management in a way that other industries really don't. So the information flow shown here in the data is actually quite understandable. It's logically representative of the relative flows and activities of information in the industries shown. My old company, Babty, which became Jacobs in 2004, my old company, Babty, designed the largest dry dock in the world, which was for Harland and Wolff in Belfast in the 1970s. And it was designed and built and commissioned in just over 2 years from the point the decision was made that Harland and Wolff needed a new dry dock because they had an order. Designed, built, commissioned just over 2 years from the decision to proceed. Now, nowadays, that wouldn't even be enough time to do the environmental impact assessment. Never mind negotiate the financial gateways and the risk reviews, write the quality plan, secure planning permission, install the document management system on the IT platform. Even allowing for that, the poor productivity record and the communication flows show a need to collaborate to get things done. And historically low investment in R&D and IT shows how fertile the construction industry is for disruptive technologies. We distribute information as much as the high-tech media companies, and we collaborate externally far more. Perfect conditions for innovation through use of digital media. So what sort of things might we do better? Excellence in project performance is usually measured around managing cost and time confidence. So where's the data kept that allows us to abstract reference cost forecasting? Where do we look for data on similar projects that the government has already paid for? Broadly, we can't, not easily. Most of it's on Excel spreadsheets, much of it in files that are kept within the companies involved with those particular projects and jealously guarded because they're commercially advantageous to keep to themselves. We do need to be far more transparent with our portfolio data. And why not? It's public money that was being used to assemble that in the first place. Why shouldn't the public see the granularity behind the project costs? Why wouldn't we welcome cold eyes review of that information through beneficial contributions? Some communities do. A bigger and a better database of project performance then would allow us to make more informed decisions on the type of project that we should be investing in, helping us to choose the right project to build when we need to. Some non-governmental organizations do quite well at making data transparent and available. The World Bank, for example, has published its independent evaluation group rankings since 2011, with data that goes back to 2004. Even though a quarter of their projects in that review are unsatisfactory or worse. So that's quite brave of them to reveal that to the general gaze. But more often than not, because of that factor, governments are reluctant and they prefer not to share the bad news. It's still quite difficult getting really good quality, independently validated, authoritative data on project performance. But some forward-looking public spenders are putting more and more data, making it more and more public. San Jose is a good example. For example, analysts are encouraged to develop tools and applications as a result of this sort of information being made available through the internet, through the cloud. And data can also help in streamlining execution. Project controls, risk analysis, contingency drawdown charts, all of that would add to the data bank of evidence that we can mine for trends, for regional variations, for sectoral variations, to help us make better decisions, more informed decisions on improving performance. And our own National Audit Office also does a good job in publishing its findings in a traditional but very, very transparent way. And data can also help us take a longer view. We don't need to build projects and say that we're done when we leave. Construction is the first phase, should be regarded as the first phase of life of that project. Optimizing the asset and prioritizing maintenance intelligently should be equally fertile ground for innovation through the use of digital data. But some data analysts working, I suspect, in a degree of isolation, they can get carried away a little bit with the potential of analysing numbers. On the face of it, this headline looks really, really promising, exactly the kind of thing that we should be doing. But read on, if you've got the appetite, concentrate on the last sentence really on this slide. What that essentially says is that we'll apply a bit of basic schoolboy maths that will say at the end of this data gathering exercise that we will save money if projects have less overspend above the original tender. That's what that says. That's what that says. And then, of course, someone will gather that together on a portfolio-wide basis, and someone in government will say that we could save up to £30 billion over the next decade if we simply improved. So the onus will come back onto the construction industry to fix itself. But actually, that piece of research that's saying we could save money if we don't overspend above the median overspend doesn't really tell us anything. There's no information, there's no depth of expert knowledge in terms of the root cause of why that should be. Is the overrun due to a change in the scope instructed by the client, which happens? Or is it due to incompetence of the contractor or the designers, which happens too? The remedies for those scenarios, however, would be entirely different. So without knowledge and review by experts, interpretation of data can be misleading. And it could even be dangerous. Here's a salutary reminder of the potential consequence of a blind cost-cutting exercise in the face of engineering safety fundamentals. The words are from a Petrobras executive before the P-36 platform sunk into the Atlantic Ocean off the coast of Brazil in March 2001. And the pictures and the words speak for themselves. So the value of learning from such disasters is incalculable, but for these very reasons, absolutely essential. And we do tend to suffer from generational memory loss, and we often repeat mistakes on a 30-year cycle. No doubt we can be imaginative enough to find new ways to fail, but repeatedly failing by making the same mistakes over and over is really stupid. So let's at least make sure that we capture lessons learned and remember them. A library of mistakes would be really, really important. In this country, safety performance actually is something we can be modestly proud of, because the trend has improved even since the late 80s, early 90s. Still, we don't deserve a pat on the back, because the fact that there are any fatalities at all is actually a failure in itself. All fatalities are avoidable. But we have come a long way, and the data since 2008-9, when I gave this talk that I've taken this slide from, has actually slightly improved even since then, although tending to plateau a bit. So some new momentum, new energy is needed into improving construction safety to the next step change of improvement. But we have come a long way from the days of building skyscrapers in New York, when developers were asked to estimate the number of fatalities that would happen during construction. That was a part of the planning application that had to go to City Hall. And the working assumption by the developers in the 1930s was 1 fatality per floor. I was delighted to find, actually, that when I came here, safety is a special study area, and that Simon Smith was supervising a PhD student on behavioural safety on the Queen's Ferry Crossing project. And we've been trying to build on that idea in conversation with Transport Scotland to try to get every publicly procured project to include similar incentives for research, whether it's on safety or other related priorities that the client might have. Even if every new project had 1 or 2% of its cost ring-fenced for strategic investment, because it would be an investment in the future through research activity, using effectively that project as a living laboratory, what a significant beneficial impact that would have. And since infrastructure spend is largely a devolved responsibility, Scotland could actually be bold enough to make that decision itself. But the problem of delivering mega projects on time, on budget, that in itself is really enough. We still don't get it right enough of the time. There's plenty of scope for intelligent collaboration between data analysts and engineering project and program managers without compromising project safety. We can and we should be using the undoubted excellence within Edinburgh University's informatics, business school and engineering collaboratively to address what really is a global issue. And I hope the development work that some of us have been doing on potential course and research offerings at the Old Royal Infirmary buildings in Edinburgh, which the university has acquired. And last week's working title was the Edinburgh Future Institute. It might be different next week, but that was the current working title last week when we had a dinner with a few invited industry guests. And that I'm hoping that some of that might mature into, for example, an MSc on leading major programs and another MSc and associated courses on resilience as a collaborative effort between engineering, the business school, informatics, and others within the university. I think we've got the right mix of expertise here to be able to do a fantastic job with that. Now, I used this slide at a meeting of the British Association in 2001 to draw an analogy between Schrödinger's jump and achieving irreversible changes in engineering infrastructure developments. Like, for example, James Watt's separate condenser, or the internal combustion engine, or powered flight. Inventions where incremental changes, I wonder if that's, I should have checked that, yeah, where incremental changes, which are the kind of norm for many periods of time, but never quite achieve enough energy or acceptance by society to get to a new equilibrium from which you never go back to the old ways. We're unlikely yet to go back to horse-drawn transport or Newcomen engines. So these changes, these step changes, take you to a new place from which you never go back. So there's enough energy, and in the case of Schrödinger, quantum jump. In our case, with infrastructure developments, it's as much about acceptance by society. That's where the energy comes from for new ideas and innovations, and they become the accepted norm from which we never go back. So I thought that analogy with Schrödinger was actually not a bad one. And I know that I've so far broken an unwritten rule of inaugurals by not having an equation. So I thought, here's the chance. But when I looked up Schrödinger's equations, none of them were short enough to fit onto a single slide. And they were certainly not simple enough that I could understand and answer questions on. So this inaugural lecture will have no equations at all. I mentioned, and we're doing okay for time, I mentioned earlier the Falkirk Wheel, that iconic image of civil engineering that comes up in the middle of that Google search of civil engineering images. And it's a bit of a bittersweet recollection for me. Babty won a commission from British Waterways in 1994 for a feasibility study about removing the obstructions to the canal system in central Scotland, the Forth and Clyde and the Union Canals, to allow navigation. And the idea then was that somehow or other British Waterways would find the money to do that. Then the Millennium Commission announced the Millennium funding opportunities, and it became a Millennium project, and it was successful. It got the funding. But most of the obstacles on the route were low bridges or lengths of canal that had been infilled to allow a road to cross. But the link between the Union Canal and the Forth and Clyde Canal in Falkirk used to be, originally, was a flight of 11 locks, long by then filled in and built over. So another solution was required. Now, I'd worked before with Rick Russell of Nico Russell Studios, architectural practice based in Broughty Ferry. And that was initially on designing improvements to the original design of the bridge to Skye, where we were both employed independently originally by National Trust for Scotland when they were objectors to the scheme. Our designed changes to the contractor's original proposals were actually implemented as a condition for NTS withdrawing their objection because they owned land on which one of the piers had to sit. So we enjoyed working together, and I'd suggested to British Waterways that Nico Russell Studios join this project as well. And Rick Russell, Andy Baxter and I, we walked the route of the canals in the Falkirk area looking for a preferred location. And we came up with the site, which was away from the built-up area on the site of an abandoned tar works, which is actually where it ended up. And apart from locks up to that time, the only other means of dealing with level differences in canals in this country was the Anderton boat lift. And this was just too industrial, old-fashioned, unattractive. So we decided to recommend something that hadn't been done before, a very large rotating mechanism with canal boats inside water tanks, so that even when only one boat was being moved, displacement of its own weight of water meant that the system remained in balance and required very low power to rotate it. The gondolas themselves were inserted in synchronized bearing rings so that they weren't suspended unstably like the pods of a Ferris wheel. And initially, it was actually a two-gondola solution like that. But traffic optimism by the client led to the four-gondola option being taken to tender at a later stage. And by that time, I was actually in Kuala Lumpur working in setting up an office for BABTI, faxing sketches meantime back to Rick with ideas for the final report. But the project was then put into pause, and we knew that it was to go to design and build as the method of procurement. So we decided that we really wanted the chance, at least, to see it through as designers for a contractor-led team, rather than remain as client advisors. So we withdrew from British Waterways and aligned ourselves. And I was back in time from KL, just in time for the competition. And we aligned ourselves with the contractor, whose price, at the end of a long story, was second. The project spec, in fact, later changed from 4 gondolas to 2 gondolas. Another design look was possible, but we had no further part to play, apart from an invitation to the official opening, which was nice. So hence the bittersweet recollections. But BABTI, at least BABTI and Nicol Russell Studios can, I think, rightly claim the conceptual design and the imagineering, if not the final engineering, of the Falkirk Wheel. And now, of course, it appears as the iconic example of civil engineering in Google Images. Damn. But no taking away from the final design. It looks absolutely great, so it had a good outcome. What are the keys to successful delivery of projects? Well, two years ago, I suggested that there were critical areas to be nurtured through a project. This is largely drawing on my time as project rep for Crossrail, 4.5 years or so, overseeing the work of the Crossrail delivery team. And my conclusion was that managing all of those areas was necessary to achieve a decent probability of success. But failure to manage just one of them was enough to pretty well guarantee failure. So there are multiple areas of attention that must consistently and continuously be nurtured through the life of a project. And ultimately, it is all about risk. That's why it's in big bold letters at the bottom. Awareness, identification, quantification, mitigation, management of risk. Risk. The truly great engineers of the past had a pretty sound appreciation of risk. A hero of mine is Thomas Telford, and he tackled outrageously difficult projects, especially for his time. But he recognized that they were all pregnant with risk. That was a phrase that he used for St. Catherine's Dock, and that his reputation hinged on minimizing those risks for a successful outcome. This man, on the other hand, Isambard Kingdom Brunel, was never happier than when tackling projects that were high risk and turning them into even riskier prospects in his zest for innovation, often to the cost of his financial backers. Both of them were innovators. Telford managed the risk of innovation moderately well. Brunel was not a risk manager. He was a risk taker. But he had a tremendous talent for managing his image. Just look at that. Now, the approach to risk taken on the London Olympics project, broadly described there, is a good example how it can use risk linked to the financial contingency, that's money set aside to deal with uncertainty and risk, and then monitor and manage both of them in tandem. The most useful graph that you can draw in a major project isn't the rate of spend, isn't the progress against milestones, it's the rate at which contingency is spent. That's the ultimate determination of whether you've got enough money in the basic pot. The direction of travel of that rate of spend of contingency is the one that will be the first to tell you whether the project will succeed or fail. And pleased to say that the Olympics didn't trade off cost management and safety in the way that perhaps Petrobras had done. Apart from an early spike, the safety performance became exemplary. And because these are rolling 12-month figures, by the way, on accident frequency rates, when you have a spike like that, it takes a full year to work it out through the system. So it just takes one bad month to affect a whole year, which is good because it keeps reminding you that you must continuously improve. In engineering, the Olympics was quite generally and widely accepted as a success story. And clearly, this headline was written when the word expert wasn't a pejorative term. And the next big project in the UK after the Olympics was Crossrail. It's a new metro rail route running from now Reading in the west, originally Maidenhead, to Shenfield in Essex, Abbeywood and Kent in the east. And in the process, going through 42 kilometres of tunnels constructed under central London and 40 stations, and 9 of those were totally new build. The cost of the whole programme was 14.8 billion, although that's a P95 cost, which means that it would be disappointing if it actually did cost that, because it means that, you know, of all of the risks that are identified, the majority of them have been materialised without being mitigated. So the hope and the expectation that we would have as project rep overseeing was that the outcome was significantly less than 14.8 billion, but watch this space. The figure that's put out into the public is the P95 figure. And I suppose it's far better PR to announce a P95 figure and deliver under it rather than, say, a P50 figure, and which has only got a 50-50 chance of being beaten. And certainly for political management, politicians hate to announce overruns, so why put them in a difficult position? It's far better to manage expectations. And the Olympics and Crossrail have been doing that very, very well. Now, Crossrail had a governance structure that required accountability to 2 masters. It's never a good starting point for a project, but it was managed through a joint sponsor board supported by an independent project representative. And in 2008, I led a Jacobs team to bid for that role, and we were successful by fielding a group of senior experts. Our job was to provide oversight and assurance to our clients totally independently from the Crossrail management team. So we were a check and a balance in the system. We provided our own view on how well the Crossrail management team and their supply chain, which peaked at about 14,000 people in total, how they were managing the strategic risks to the programme. My team was resident on the project. We had full powers of access. We sat in on senior meetings. We could do deep dives into particular areas of emerging concern. And we wrote independent monthly reports with a different perspective and using wider benchmarking than the Crossrail delivery team focused on their immediate issues and problems. Another major benefit was that, as well as the client receiving an independent view, the chief exec of Crossrail also got an independent view of his project. And whilst sometimes it might have been unpalatable, it prompted immediate action. It was an extra check and balance for him in balancing the information that he was receiving upwards internally. So a robust and respected independent peer review is money really well spent on a complex project. In fact, any project that can afford that. And all of them should. Now, Crossrail has got, as I mentioned, 42 kilometres of tunnel in total, and fortunately techniques have moved on a bit from the first tunnel that was built under the Thames by Mark Brunel, although the basic principle of advancing shield with muck taken away from the face actually does remain the same. But in Brunel's time, the hazards of underwater tunnelling were still being explored and understood. And after several floods like this, it's to their credit that they managed to complete the tunnel at all. Major achievement for them. But young Isambard cut his teeth as a resident engineer on this project. And on one occasion, he did actually almost drown in one of the roof penetrations, which you would have thought must have shaped his view of engineering risk-taking, without surprisingly making him risk-averse. Our modern equivalent of the Brunel tunnelling shield is the tunnel boring machine. And one of the burdens that civil engineers, by the way, have to bear is being the butt of that cross-reference in yellow pages, boring, see civil engineers. Well, there's nothing boring about these machines. Well, actually, there is, I suppose. They're boring for Britain right now, you know what I mean. Anyway, there were 8 of these on the Crossrail project, all of them built in Germany, boringly. And the key principle behind them is to maintain just enough pressure on the excavated face to match the pressure. I'm going a bit fast. To match, I clicked again. To match the pressure exerted historically by the soil that is removed, so that on the surface there is virtually no change perceived, despite what's happening down below. So the pressure on the face, if it's balanced with the pressure that pre-existed from the soil that's being removed, means there's minimal disturbance on the surface. Now, to get that to zero is impossible, so lots of chemical grouting goes in above the TBMs. But there was a really good outcome on Crossrail, and the settlements and the subsidence on the surface was very minimal, less than 40, 50 millimeters. And these machines are about 7 meters diameter, by the way. The man this man, on the other hand, was never. That's the operating platform for the machines. That's the flight deck, if you like, of the tunnel boring machine. And this man here operating that machine without his hard hat. No hard hat required in the tunnel, given what's above his head, but it is there, ready for the change of shift, part behind the screen. This diagram kind of demonstrates how difficult and tricky it is to thread new tunnels beneath London, and they also demonstrates the advantages of 3D modelling, using building information modelling to really understand the interaction between the underground, utilities, and all of the other obstructions that you get in a city like London. And one of the most congested areas was round about Moorgate, where you had the Post Office Railway Tunnel, Metropolitan and Hammersmith City lines, a sewer, the Northern Line intersecting, and escalator shafts that had to go between the sewer and the Northern Line. Incredibly tricky setting out underground, but successfully achieved. And to finish with a small flavour of Crossrail, here's one of the actual TBMs. And all of the TBMs are named after women traditionally. This one's called Sophia. And this was one that tunnelled underneath the Thames. Now, the National Audit Office reviewed Crossrail in about 2014 at about the 60% stage or so. It's about 80% now. And I'm pleased to say that they agreed that the independent role of the project representative was proving highly beneficial. It's not finished yet, it's still not a proven success, and there's plenty of risk left in the system, but it seems to be maintaining its cost and schedule targets quite well, and it's not operating under an unregulated global market economy, if you remember that phrase from the Petrobras disaster. It's quite highly regulated. It's got the continuing presence of the project rep as an independent peer review, and it has full accountability up to government ministerial level. Anyway, it was all right when I left. So infrastructure can be high-tech. It can be automated. A lot of it is. And it can be, and a lot of it is, hugely creative. It's just not yet quite cool enough to really attract more interest from young people. Well, maybe that's about to change. Despite all of the money being spent on Crossrail, all of the money potentially being spent on HS2, perhaps conventional rail won't be the transport of the future. Look at these eye-watering journey times. The University of Edinburgh student team, hyped, some of whom are here this evening, yes. They've been working on competitions that were launched effectively really as open source ideas generation by Elon Musk, who's proposed the concept of the Hyperloop, using a hybrid, sort of a hybrid of maglev compressed air technology in vacuum sealed tubes. Average speeds of 760 miles per hour are thought to be possible. Pretty fast. Elon Musk himself doesn't plan to build the Hyperloop, but he's offering the idea to others to develop and take the risks. Student competitions are part of this ideas generation, which is a really neat idea. And the Edinburgh team last year travelled to Texas, came back with a trophy, so well done them. But it's fantastically exciting and interesting and really deserves the opportunity to develop. It might be the next one to burst out of the trough of today's norm in Schrodinger's jump diagram. The images of Hyperloop tend to show elevated tubes, but the challenge of threading straight or gently curving routes through a congested country like the UK might actually make tunneled tubes a better way and perhaps the only way to deliver it, despite the higher apparent unit cost. But with long enough lengths to be tunneled, unit cost of tunneling should reduce as the market responds, funds improvements and efficiencies. So time will tell whether the Hyperloop moves from science fiction to science fact, but at least Elon Musk is pushing at the boundaries and he's helping to make engineering cool. And just to demonstrate how important it is not to underestimate comics as potential source of inspiration, the PR image that I chose for this lecture, that you've probably all seen, it's in the handout if you haven't, came from this comic in July 1966. It's the 1960s version of the Hyperloop. What foresight. And note too that in 1966, I'll flag up this next one, work was expected to start on the Channel Tunnel in 2 years' time. So in 1960, in fact, it was to take another 22 years. It was finally built between 1988 and 1994. So is this another clue why productivity hasn't improved in 50 years? We spend a very long time deliberating on major projects. Here's another fantastic image from comic culture, an elevated propeller-driven transport system. This wasn't science fiction. It was the George Benny railplane. And it had a test track built near Milngavie, just north of Glasgow, in 1930. And Benny thought his system could reach 120 miles per hour, but he couldn't get any financial backers. The prototype test track lay mouldering for many years. It was finally sold for scrap in 1956. So George Benny, unfortunately, didn't have Elon Musk's deep pockets or the opportunity to crowdsource free brain power, and he paid for it all out of his own resources until he had to file for bankruptcy before it was taken up. An interesting example of, looking backwards to learn from the past. In fact, further back again to 1847, which was the height of the railway boom, and Brunel's South Devon Atmospheric Railway. Now, this was an attempt to create a railway that didn't need locomotives, which were heavy to take, under their own motive power. So the idea was find some other way of propelling the carriages. And a slotted pipe was laid, and carriages with pistons attached were conveyed by pumping air out of the pipe ahead of the piston to create a differential pressure. The whole system was a machine as a result of that. In fact, it was a system of systems, and a single leak anywhere in that system brought it to a halt. And the location of the leak, when it happened, was unknown. There were no sophisticated sensors, fault tracking feedback in those days. So maintaining the integrity of a 34-mile long machine susceptible to weather and to rodents, because the rats like to nibble on the tallow-coated leather that covered the slot until the carriage passed through. That proved to be, as many actually expert engineers had told him, like Robert Stephenson, educated at the University of Edinburgh, it turned out to be impossible, impracticable, and the scheme had to be abandoned. Now, it's interesting that when you read the accounts of the Hyperloop, some of the Hyperloop skeptics, they cite dirt and grime in the system and capsules getting stranded miles from a city. More successful, this electrified cable aerial transportation system was developed by our first Regius Chair of Engineering, Henry Charles Fleming Jenkin. It was called the Telfridge system, and the first one was built in Sussex in 1885, opening just a few months after Fleming Jenkin had died. And this sketch conveniently shows both of them, the man himself and his invention in the background. And when I looked at this slide, this image first, it reminded me of something. I couldn't quite place it until it came to me in a flash, literally in a flash. In fact, there you have Fleming Jenkin boldly holding the exposed wires, about to contact with absolutely no protective goggles or gloves or anything, so not exactly a safety model. But then I realized what it was that it was reminding me of. It was this slightly better equipped individual who at least had safety goggles on. Look at that. So Fleming Jenkin was our very own Doc Emmett Brown. Come to think of it, he might even have been Doc Brown. So we've come back to the future again. Now, I mentioned earlier the fatal flaw of forecasting is the difficulty of forecasting step change disruptive technologies. By definition, you can't know what you don't know. Even Robert Choate, who's the chairman of the Office for Budget Responsibility, whose job it is to forecast the economy, has said all forecasting is landing a jumbo jet on a postage stamp. But this hasn't stopped Innovate UK indulging in a bit of speculation. That's their job too, after all. So let's have a quick look at Innovate UK's vision of the future.
Hello, I'm Sunny Rita Schroff and welcome to the first episode of Predictions by Innovate UK.
Today we're going to look at the inside of your home and how it might look a couple of decades from now. Most of the developments we'll look at will depend on the Internet of Things, where devices are capable of sharing information with each other. The Internet of Things is already happening. It's possible to control your thermostat or home lighting using your phone, and a voice command can have you booking a doctor's appointment. So what's next in our ever-changing relationship with technology? Well, I'm here with Johnny Voon from Innovate UK to help answer this question.
Well, domestic technology will become increasingly intuitive. You could say intelligent. Homes will learn about our habits and patterns, analyze the rhythms of our lives, and be able to read our facial expressions and body language. Walls and surfaces will become interactive touchscreens, so we can seamlessly engage with the world without needing a dedicated computer or device.
I mean, I find that all rather amazing, to be honest. Now, tell me about a normal day in 2036.
Imagine your bedroom waking you up at just the right time and the right way for you. Your wardrobe will cross-reference the weather forecast and latest travel information and present you with a suitable outfit to wear and journey to take. In the bathroom, sensors measure your blood pressure, heart rate, and scan your retina to check your health and send any concerning results to your GP. When you get home, your kitchen will tell you which food items are about to go off and suggest recipes to avoid wasting them. If you were running low this morning, your fridge will have placed an order to replenish your stock for you to collect at the most convenient place on your way home. The Hob's interactive surface will guide you through your recipes as you cook. If you're hosting a party, it will sync with your other guest list and adapt quantities as people confirm or cancel.
Now, how do you think people will react to having their lives managed like this?
Obviously, information protection will also evolve. But think about this. People are living longer, and problems with mobility and memory are only going to increase. Soon, mirrors and walls can become screens through which to speak to our doctors. Our homes can give people prompts to look after themselves, monitor vital signs, and alert emergency services if necessary. This will give vulnerable people unprecedented independence and comfort and relieve pressure on families and carers.
Now, if you want more information, check out the website Innovate UK, and of course, do stay tuned because we'll be bringing you more videos soon.
Now, I've got mixed feelings about that. Part of me was really impressed, and part of me was really creeped out. As George Orwell said, don't worry about watching television, but beware of the television that watches you. And did you notice there were more refusals to the dinner party than there were acceptances? But, you know, are these the sort of improvements, perhaps more thoughtfully, are these the sort of improvements that are going to do anything, you know, for people who live in favelas in Brazil or shanties in Mumbai? Or will they just widen a gulf between those who can afford technology like that and those who can't? Would that create social unrest? Or perhaps they're liberating technologies that will equally advance well-being in developed and underdeveloped parts of the world? I don't know. But it's important, I think, that we put some effort into researching it. But having established so far, I hope that the construction industry and infrastructure is ripe for innovative change. It's got many problems still to be solved and a relatively immature embrace of digital solutions and informatics. I do think that digital technology, digital techniques is the most likely means of nurturing the step change breakthroughs. And so does the current president of the Institution of Civil Engineers, I'm glad to say. Tim's theme this year in his presidential address was engineering a digital future. So, what disruptive technologies show the most promise? I guess the exciting untapped areas, undeveloped areas for infrastructure applications are related to the cloud, mobility, the handphone and the power of that, Internet of Things. Saw some of that there in the video clip, big data and combinations thereof. And these were the areas back in January that I thought were ripe for research activity, some of which we've already touched on. As far as the cloud or large-scale data storage is concerned, whether it's the cloud or big entities like EPCC, for example, that can help us disseminate best practice, hold vast libraries of mistakes if we choose to, and databases of national performance, all helping to reduce costs. Smarter mobile devices will give us even better access to the bandwidth that we need right through to the job site, the construction site itself. And the Internet of Things in a construction context could be used to embed sensors more widely than we currently do. For example, alarms could be set off if people stray into no-go areas. This might have actually prevented the only fatality so far on Crossrail when freshly sprayed concrete dropped from the roof onto a worker who shouldn't have been in that area. It was a temporarily sensitive zone, and despite the notices which were up. Which flags up one of the key weaknesses in our systems, in our system of systems. It's not necessarily always the hardware or the software that fails. It might be the wetware failures of human error. So sensors can give us real-time information on when concrete has set to allow the next phase of construction to proceed, striking of shutters, for example. Sensors could check the vibration effects of adjacent work on sensitive work alongside. Sensors could reduce the buffer time between successive events in a schedule that's quality dependent, like the time that you can safely strike formwork from concrete, or when it's okay to backfill against a retaining wall. And at the core of program delivery is efficient sequencing and schedule of activities. So if we can be smarter about that through regular embedded sensor feedback, we ought to be more efficiently in our build time. And big data for data storage and mining. Although paper plans are diminishing in favor of digital, many of the subcontracts, payments in construction, they still adopt paper payments, paper records, paper variation orders, paper change control, especially as you go down the supply chain. So how hard do we want to make it to analyze trends? So simply digitizing change control would be a really valuable data set on a major source of cost overruns. Too often in the history of construction, history of infrastructure, we know that there's a problem, but we simply don't have the data amassed or sorted to be able to take the next step in analysing root cause really effectively and therefore remedy. So it's all there, but it's relatively inaccessible. And that's one of the things that does need to change. We need to augment intelligence with data and vice versa. And the broad sweeping statements of the bleeding obvious that many projects exceed their first estimate, they're not really terribly helpful without expert understanding. The bullet at the bottom of this list may actually be about to be taken forward as a collaboration between engineering and the business school on a 4-university group task funded by the Project Management Institute under a program called, launched by the Infrastructure and Projects Authority. The program is called, somewhat mysteriously, Project X. Now, Project X, that is really cool to be working on if we do see that happening. So, just in that case, just as we're going to be exploring the change of value with time, and just as value does change with time, so perhaps do our perception of what success looks like. Do the events of 2016, which we've all experienced, also mean that we've already got a different view of what a successful nation looks like? Should we be paying a lot more attention to the data that shows divergence between sectors of society? This one, for example, shows living standards have increased since 2007 for the over 60s. That's good news for some of us. But decreased for the under 30s. So, should we be thinking about, right, okay, what can infrastructure development and research do to help address issues like that, if anything? The country of Bhutan has actually decided that its measure of gross national happiness is as important to it as its gross domestic product. I love the definitions on this, by the way. They've got categories, if you can read them, of deeply happy at the top, extensively happy, followed by narrowly happy, followed by unhappy. So there's only one definition below the median of unhappiness. There is no definition of deep unhappiness. It's probably because they didn't want to reinforce people that were in that space into the next step of deeply depressive behaviour. I'm not sure. Even our own National Statistics Office produces a slightly more complicated Wheel of National Wellbeing, which is an interesting but still relatively immature attempt to measure happiness. And our first PhD student in our virtual Centre for Future Infrastructure, Henrietta Windsor, is attempting to realise some of the potential of the huge volume of forensic data collected about past and present infrastructure. Avoiding failures by learning from the mistakes or the near misses and increasing the probability of success. Definition of infrastructure, probably should have started that with that, but it's broadly there on the slide: transport, power, water, waste, communication, and importantly, people. People are part of the system of systems that makes our infrastructure success or failure. Some people are a strength, but they're sometimes a weakness. And one early finding, actually, that Henrietta has discovered in our consultations is that people clam up when the F word is mentioned, and the F word is failure. And Elon Musk, we've got to thank again for popularizing a term that was first coined in the 1960s, because Elon Musk has told us this is not a failure. It's a rapid, unscheduled disassembly. Or even more distance from the F word, an RUD. I think it's quite a clever approach to dealing with the semantics and the terminology. Two other students, Marcus Wright and Thomas Findlay, are studying how to define infrastructure success in a way that links more closely to happiness or well-being through the established Sustainable Development Goals and figuring out infrastructure's contribution to those, which I think is a really clever angle into truly valuing infrastructure as a way of measuring success. And we have another pair of MEng thesis students, Dean Shafar and Matthew McFarlane, who are reassessing performance indicators for road transport and for walking and cycling. And Cameron Bain and Jamie Thompson, they're reviewing how successful we've been with our forecasting of infrastructure needs historically, and perhaps, hopefully, might be some lessons on how we might improve. So, despite having only been here for about 6 weeks, there does begin to feel that there's a growing interest in future infrastructure as a rich source of collaborative research and teaching opportunities. And in my view, it must be as cross-disciplinary as possible. We live in a world of multi-dimensional complexity. There are no single discipline problems, if ever there were. Infrastructure isn't just a systems problem, it's a system of systems, complex web. For instance, if we lost GPS capability in a critical satellite, we won't be able to dock our supertankers properly and safely now. That means we would have a delay to getting fuel to refineries in time for the next distribution for transport and power. Then we'd start to get local blackouts. Food might not be distributed in a timeless fashion. So without effective and resilient infrastructure, systems of systems, some have estimated that we're about 3 days away from anarchy. And if the system of systems is dependent on one critical satellite controlling the docking of supertankers, I'd kind of like to know that and draw attention to a critical lack of resilience, if there is one, so that something can be done about it. Better still, that several somethings can be done about it. At the moment, in many cases, we don't even understand these critical dependencies until they happen, like a single fractured steel tie on the Forth Road Bridge. And we saw earlier that the piece of kit most associated with engineers is the hard hat. Now, here's another taste of a possible future that will affect the very thing that society clearly associates most with civil engineers. And it might just transform the image of the civil engineer. It'd be pretty cool to wear one of these, even if it's only for a small part of your working life. I tried to get a bit more information on how to get hold of one of these, actually, because they do exist and I really, really want one. The latest developer edition was released on the 31st of October for, it was a snip really, at $15,000. But if it does mean that workers can identify hazards, reduce injuries, save lives, as well as the smart data gathering and logging capabilities, it might actually transform the construction industry. And the price will come down. So tonight we've been looking back, ladies and gentlemen, in history a bit, and at attempts by others to influence or to forecast the future. The latter I vow never to do with confidence, because it's not about trend extrapolation. Apart from anything else, at the moment, you kind of feel that that would take us to a depressing place that I really don't want my grandchildren to experience. All we really know about the future is that it will be different, so we've got a duty to try to make it as good as it can be. And infrastructure, I hope I've helped demonstrate, is critical to our happiness and our well-being. It's time to research the hell out of it. And infrastructure can also be inspirational, even if it's not the Falkirk Wheel. You've probably walked past this escalator many times. It's in Waverley Station. And did you ever notice that there were words by Sir Walter Scott etched onto the side? And that makes it the most inspirational escalator on the planet right now. And I want to give the last words to someone who we've met already, and whose wise words fit the theme and the message of this lecture remarkably well. His greatest achievement demonstrates how the past enriches the present without enslaving the future. And he uses hindsight, which gives him insight, and nurtured that into foresight, the continuum from the past to the future. And that's kind of why I enjoyed my experiences so much as a commissioner on ARCAMS, by the way, the influence of the past, the understanding of the past to appreciate the future, make better informed decisions. The words you're about to hear hint at great deeds by Scottish inventors like Fleming Jenkin, great words by the Wizard of the North, and I like to think also that these words sum up a future where the greatest contribution to the planet's quality of life has come from a small nation on the fringes of Europe, that invested wisely and deeply in its higher education and research to create a body of experts that were so influential that they earned themselves a universal phrase applied to anything showing an astonishing degree of excellence and ingenuity. And the image problem as a result for engineers has been well and truly overcome. So what am I talking about? What are these words? What else but Doc Emmett Brown saying, "Great Scott!" Great Scott. So, ladies and gentlemen, wouldn't that be a future worth backing? Thank you very much.
What I would say in the very short time that Gordon has been with us, only 15 months, he's a wonderful colleague and he's always looking forward. And that's true even when he's indulging his hobby in the history of engineering, as you have seen this evening. So future is written through Gordon like it is written through a stick of rock. And I'm sure you'll agree with me that as far as the Chair of Future Infrastructure is concerned, we've got the right man on the job. So thank you very much, Gordon, for your lecture this evening.
Thank you. Thanks very much.